Hello everyone. Let's start with the next part of your mole conversion calculation. So today I'm gonna show you a conversion of moles into number of atoms or molecules, if it's a molecule, as well as formula units. Sometime you will see in the question it's mentioned formula units. Formula unit means your compound is ionic compound because there are two units, cations and anion. Formula units. Here we go. So this is our next part. So let's start with the question. Let's say you have, this is the question. How many moles of carbon dioxide need for an experiment if 12.04 times 10 raised to the power 24 molecules are given to you, so of carbon dioxide. Okay, here is the question. So in this question, molecules are given to you. You want to find the moles. Okay, so it means you need that known information where you have moles and molecules together. So it's very, very important for the conversion factor. Use that known information. The unit you want to cancel and the unit is given to you in the question. So we know for carbon dioxide, moles and molecules, 1 mole of carbon dioxide is equal to 6.02 times 10 raised to the power 23 CO2 molecules. Here we go. So this is our known information, molecules and moles. Same pattern, same steps, 3 columns. First column, the number given to you in the question. Third column, what do you want to find? So we want to find the moles. Here we go. So write down the value given to you in the question. It's 12.04 times 10 raised to the power 24 molecules. Okay. So in the third column, you need to find the moles. Put the moles here and here the conversion factor. So one value will divide with the value in the first column and one value will multiply. Same rule, same unit should not be multiplied. They should be in division form. So we know we want to cancel the molecules. So right hand side will be your denominator. We will write 6.02, your mole number. 23 molecules as a denominator. Write down 1 mole as a numerator at the top. Molecules out, they are cancelled, and rest is your calculator part. So you can see it's pretty easy, 1 and 2. So it looks like your answer is 20 moles. So here we go, 20 moles of carbon dioxide we need for the your experiment. Let's take another example. Let's take your atoms. So yeah, I'm showing you the simple example. First, you need to know about the basics of mole conversion calculation. Then I will take you to the advanced level of the problems. So let's take how many atoms of mercury need for a reaction if, let's say, 2 moles of mercury are given. Here we go. So that's our question. You can see what is given to you. 2 moles are given to you. And what you need to find? You need to find atoms of mercury. So it means you need that known information where you have moles and number of atoms together. So what do you know for mercury in terms of mole? Standard known information. I know 1 mole of mercury atom is equal to, in terms of number, 6.02 times 10 raised to the power 23 mercury atoms. Here we go. So write down what is given to you in the question in the first column. What is given to you? 2 moles are given to you. We'll write the middle column last. So what do you want to find? I need to find the number of atoms. Whose atoms? Atoms of mercury. So you want to cancel the mole. You want to find the atoms. So pay attention in your known information. This is very important. So yes, you want to cancel the mole. Put the 1 mole as a denominator. 1 mole at the denominator. You want to find the answer in atoms. Put 6.02 times 10 raised to the power 23 atoms of mercury at the top. Here we go. 1 mole cancel. Rest is your calculation. You can see you have to multiply 2 times 6.02. I will say it's 12.04 times 10 raised to power 23. In calculator, if we change into scientific notation, so your answer is also 1.204 times 10 to power 24. So pay attention that you're using calculator or you're doing the math mind calculations. So yes, so this is one method. Let's take one more example. I want to show you now different example. So let's say I have given you in terms of moles, 1 mole of H2S. What else you can write? We know 1 mole in terms of number is 6.02 times 10 to the power 23 molecules of H2SO4, and 1 mole is equal to 98 grams of H2SO4. It's molar, standard molar mass. But what else you can write? This is 1 mole in front of this whole formula. What do you have inside the formula? You have 2H, you have 1S, you have 4O. Can we write these atoms in terms of moles? Yes. So very important. So 1 mole of H2SO4 is also means 2 moles of hydrogen atom. Kids, they usually do mistakes here. So very important. If you're writing 1 mole in front of the formula, it means this mole is a property of each and every atom inside the formula. So, or I can write 1 mole of sulfur atom. Here we go. Or I can write 4 moles of oxygen atoms. Here we go. So it's very, very important. Okay. So I'm gonna use this formula. So I'm gonna show you the different form of the question. So let's take. So I hope you understand the concept. So I'm gonna erase only this part, and here is my question. How many atoms of are present? I'm using very simple word, present, in 4 moles of H2SO4. Here we go. So this time I have given you 4 moles of H2SO4. So very important. If you understand the basic concept, then it's very easy. So let's see how to deal with this type of question. So first of all, what do you know? I know 1 mole of H2SO4 has, what do you have? I have 4 moles of oxygen atoms. Alright, what else we know? Now, so this is your known information, but your question is for 4 moles. If 1 mole has 4 moles of oxygen atom, what about 4 moles? Can we find? Yes, 4 moles of H2SO4 has 4 times 4 is equal to 16 moles of, this is 16 moles. Pay attention. My question is how many atoms? So it means you have to convert these moles of atoms into actual atoms. So very important. Okay. So it means same concept. Here we go. You want to find the atoms here. All right. So what is given to you? 16 moles of oxygen. I hope you understand what I'm doing. So you want to cancel the moles, put 1 mole of oxygen atom at the bottom and change into number pure atoms. 6.02 times 10 to the power 23 oxygen atoms. Moles cancel. So rest you just need to multiply and you will be fine. I can show you the calculations here. So 6.02 times 16 is equal to 96.32. Answer is 96.32 times 10 raised to the power 23 atoms. So this is for atoms. Maybe there will be question how many grams of oxygen are present, let's say the given moles of sulfuric acid. So same pattern. So be very careful, read the questions properly, make an image in your mind, make a flow chart. First of all, write down what do you know, means what is given to you. It's very important. Thank you so much. We'll do